So we're going to look at formula, molar masses, and we're going to do a few little conversions here, just going from grams of one to maybe moles of another, like grams of one compound to moles of that same compound. In order to do that, we need to know how to find the formula or molar mass of a compound, which is pretty simple. All you do is you take the mass of each of the individual elements and you add them all together, and then that gives you the mass of the compound. So for like water, H2O, H is 1.01. So you multiply that by 2 because there are 2 hydrogens there. And then oxygen is 16. So you add those together and you get 18.02. When we deal with the masses from the periodic table, it's a good rule of thumb you can round out to 2 decimal places. Round to 2 decimal places. Whoops. So what is the molar mass of these compounds? KClO3. Ooh, good review. What is the name of this compound? Potassium chlorate. Yes. ClO3 is chlorate, so potassium chlorate. So what is the mass of potassium? What is it? 39.1? 01? 10. Okay. Plus, what's chlorine? Yep. Plus, oxygen is 16. Yep, times 3 because there's 3 oxygens. Or you could have 16 plus 16 plus 16. You'd get the same. So what is that total? 123.55. Do we have someone that? 122. You guys agree? Good. That's a 2. Come on. Our units for this is going to be grams per mole. Grams per mole. Not of a compound. H2SO4 is sulfuric acid. So hydrogen is 1.01, and there are 2, plus what's sulfur? Plus, then oxygen is 16, and there are 4. .12, and that's grams per mole also. That's the name of the next compound. Calcium nitrate. NO3 is nitrate. Calcium nitrate. So calcium, what do we got? 40.08. Plus, okay, now how many nitrogens are there actually? 2. So nitrogen is 14.01. And there are 2 plus 16 times how many oxygens are there? 6, yes. We'll multiply by 6. Remember, this 2 will carry through here, through the parentheses. 164. 1, 0. You guys agree with that number? Yeah? Okay. What's the name of the next compound? Barium hydroxide, yep. So barium 137.33 plus how many oxygens are there? Plus how many hydrogens? I know, it's getting bad, the glare is. 1.01 times 2, so what do we get? What was it? Okay, what's the next compound's name? Sodium nitrate. So sodium is 22.99 plus nitrogen 14.01 plus 16 times 3. 85 even? You guys agree? Yep, okay. And the last one, what's the last one's name? Sulfate would mean there's an oxygen in there. No oxygen. Aluminum sulfide. Right, we take the sulfur, change the UR to IDE. Sulfide. So aluminum, what do we got? 26.98. And there are how many? 2 plus sulfide. 32.07. And there are 3. 150.14. There you go. So pretty straightforward. Just adding all those together. But we are going to use these now as conversions. So we're going to use them as a conversion factor where we can use it as grams per mole or moles per gram depending on what our unit we start with. So if we go with this first one, the mass in grams of 2.5 moles of oxygen gas. Now oxygen gas, what is the formula for oxygen gas? Actually, I'm going to get a new piece of paper. So we have 2.5 moles of oxygen gas. What's the formula? Is it just O? It's one of those diatomic molecules. Remember the diatomic molecules? There's 7 of them. You can either draw 7 on the periodic table and then add hydrogen, or you have the saying, I brought clay from our new house. So oxygen is diatomic, meaning that it's going to be O2. So what units need to be on bottom? Mole. And the units on top? Grams. Right. And the mass that we have up there is grams per mole, so it's the mass of 1 mole. So it's always going to be 1 mole right here. Disconnected. Put 1 mole in there. What's the mass of O2? Yeah, 32. Oxygen is 16, but there's 2 of them, so we multiply by 2. So we'd have 32 per 1 mole. And they ask for grams, so that's all we have to do there. 80? 80 grams of O2. Good. What's the next one? Okay, so we start with what we're given. How much do we have? We have 0.237, 0.257, oops, moles of calcium nitrate. We need to know the correct formula before we can add up its mass. So we have Ca and NO3. Right, calcium was 2 plus, nitrate's a minus 1. So we put this 2 down here because we need 2 nitrates to balance out the calcium charge. So we'd have Ca, NO3, 2. There. We're changing it into grams. So units on the bottom need to be moles, and we can go from moles to gram because we know we can find the molar mass. What's the molar mass of calcium nitrate? Is that one that we did already? 164.10 if you look at the ones we added up previously. So what's our answer? Because moles are going to cancel out. And actually, it's probably a good idea to get in the habit of writing out what compound we're dealing with here. Because in a couple chapters, we're going to be converting from one compound to another. So it's good to just keep that straight. 42.17? 42.17 grams of calcium nitrate. So we've done this before, just using only one element. Now we're adding, it's just the same process, just with the whole compound. What's the next one say? How many moles are in 3.82 grams of SO2? So how much SO2 do we have? 3.82 grams of SO2. We need to know how many moles. So what units need to be on bottom? Grams need to go on bottom this time. Moles can go on top. We're going to know the mass of 1 mole. 64.06. The O2, 16 times 2 is 32. Mass of sulfur is 32.06, so add them together and you get 64.06. So you're going to divide this time. What? 2 decimal places is fine. 0.06 mole of SO2. Okay, then there's a second question with that problem, right? It's asked how many molecules. So when we calculate molecules, we're going to do it the same way as when we're dealing with just a single element. We're calculating to atoms because they just are the same atoms. We can't really calculate to atoms, so we calculate to molecules, but we're going to use what number then to convert to molecules? Avogadro's number. So we'll start with moles because that is how many molecules are in a mole. So we can start with that 0.06 moles of SO2. And 1 mole of SO2 then would have how many molecules? 6.022 times 10 to the 23rd molecules of SO2. So our moles cancel out, left with molecules, and .25th. Oh, that makes more sense. .61 times 10 to the 22nd molecules of SO2. Now remember, on a lot of calculators, you have to put Avogadro's number in parentheses. That way it calculates it correctly. Good. Is there another one after this? Yeah, ibuprofen. So ibuprofen, it's C13H18O2. Okay, its molar mass, it already added all that up for us, is 206.29 grams per mole. Okay, so if the tablets in a bottle contain a total of 33 grams of ibuprofen, how many moles of ibuprofen are in the bottle? So we have 33 grams of ibuprofen. We're going to put the molar mass, so grams need to be on the bottom, correct? So we're going to have the 206.29 grams per mole. Oops, not grams per mole. If we did that, it would be right, but grams, and then 1 mole on top. We have 0.16 moles of ibuprofen in that bottle. How many molecules are there? So if we have 0.16 moles, 1 mole has how many molecules? .64. So 9.64 times 10 to the 22nd molecules. And then the next problem asks, what's the total mass in grams of carbon in those 33 grams of ibuprofen? So just of carbon. So what we're going to do, I'm going to start a new page here. 9.64 times 10 to the 24 times 10 to the 22nd molecules of, I'm going to just say IB for ibuprofen. Oops, that's molecules. You know what? This is going to make more work. Scratch this. Let's start with the 33 grams of ibuprofen. So we already know it's 206.9. Is that right? 29. 206.29 grams per 1 mole. So we do that first step first just because we need to get to moles. Now once we're in moles, you can do a lot of converting from one compound to another or from a compound to an element. So ibuprofen was C13H18O2, right? So how many carbons are in 1 molecule of this? 13. So if I have 1 mole of this, how many moles of carbon are there? 13, yeah, same. Because it doesn't matter if they're both in moles, you can convert it that way. So in 1, that's why I want to keep using the IB here. In 1 mole of ibuprofen, we have 13 moles of carbon. So moles of ibuprofen will cancel out. Does everyone understand that step? So now if I'm in moles of carbon, is that what the question asked for? Grams. So can we convert moles of carbon into grams of carbon? Because we know the molar mass of carbon. 1 mole of carbon weighs... Yep. 24 point... Everyone agree? Because we don't have a total of 13 moles of carbon, because we only have 33 grams. If we had a full mole of ibuprofen, if we had 206.29 grams, then yes, we could do that. Any other questions? Okay, and this next little part, we're going to do percent composition, then we'll be done here. Because percent composition is looking at the percentage of mass of an element in a compound. So you take the mass of the element, the total mass of the element, divided by the mass of the compound times 100. This next. So if we do an example here like this, for percentage composition of copper 1 sulfide, we need to find the percent composition of copper first, and then of sulfur. So how much mass of copper do we have here? 2 of the coppers times mass of copper is 63.55. So we'll have 63.55, but there's 2 of them, so let's multiply by 2. And then you're going to divide by the mass of the whole compound. So we need to add 32.07. $159.17 is the mass of the whole compound. So you take this and multiply by 100 to get a percentage. And what is that? %. Now there's a couple different ways, since there's only two atoms in that or two elements in that compound. What should be the percentage of sulfur? 20%. They should add up to 100%. Or you could take the mass of sulfur is 32.07, divide it by the mass of the compound, and multiply by 100, and you should also get 20%. But when you add up all the percentages of the whole compound, you should get 100%. That next problem is exactly the same. I want to go to the following problem, and then you guys can have some time to work. Because this one, we're looking at, so a hydrate is when they form these crystals and there's actually water molecules trapped in there, and so they call them a hydrate. This is sodium carbonate decahydrate, so there's 10 water molecules trapped within one of these crystals, and it gives us the molar mass already. It wants to find the mass percent of just water. So we have the mass of water, is 18.02, and how many water molecules are there? Aren't there 10 water molecules? Times 10 H2O on there. And then it gives us the whole molar mass already, so 286.14 times 100 will give you your percent of water. So I just want to show you can do a hydrate in this way. You're just looking at the mass of water over the whole compound. Now when they added up this molar mass, they included those 10 water molecules. So if you end up having to find your molar mass of the compound, you add the 10 water molecules. Did anyone calculate that percent? 63? 63%. Good. Okay, so you can work with a partner right now on this worksheet.